Hi students, in this video we are going to learn some more basic concepts of eye. See here, first we may think here least distance of distinct vision. Least distance of distinct vision. Simply it is called LDDV. What is this LDDV? For that purpose, we may do small activity for that. See here, I have some printed paper along with me. Now, of course, you can use the textbook also. See, I am going to keep the paper here like this. Can you able to see the paper? No. Move the paper here. Yes. The letters that is there on the paper becomes blurred. Now again, little bit okay. We can read that paper and otherwise what are the printed items easily. Right now. So see here, now I am able to see the paper clearly, very clearly. If you measure the distance between my eye and as well as the book, at this distance, at a particular distance, I am able to see that printed material in a comfortable manner. Means there is a minimum distance is there between the eye and the printed material. That minimum distance is called least distance of distinct vision. Distinct means we can see the images very clearly on the printed material. See the definition of LDDV are also called least distance of distinct vision is the average least distance between the eye and the object which we can see the object comfortably and accommodatedly. See, this is changes from person to person and with age also, means person to person age may change. See, in the case of the kids, generally the kids will see easily. Why? Because they have sensitivity of vision. This means below 10 years the value of LDDV, least distance of distinct vision, is 7 to 8 centimeters. Means the kid which below the 10 years, they can see very clearly, which we kept very close to the eye. In the case of old age, means above 50 years, the least distance is nothing but 1 to 2 meters. For that sake only, the people more than 50 years, they put the book like this and then they use it to read. This means the LDDV value is 1 to 2 meters in the case of old age people. But an average means either it may be below 10 years or above 50 years or whatever it may be. On an average, the value of LDDV is 25 centimeters. Means if you put the book at a distance of 25 centimeters, we can read it in an easy manner. For that sake only, our doctors, ophthalmist will say like that, sit in a proper manner and the light should directly fall on the textbook or otherwise whatever it may be the reading material position, then and there we can read easily without having any eye problems. Right, let us learn one more concept, that is MDDV, maximum distance of distinct vision. See now here, maximum distance of distinct vision, MDDV. Before we learn LDDV, it is the average highest distance. Generally, our eye is able to see the object very close to the eye and at the same time at a very far distance. For example, say it may be at long distance also we can see those are all the things. Whenever you went to the top positions, means highest buildings, sometimes you can see long distance objects also. Means, but they are not clear, but we are able to identify whether the object is there or not. This means we are able to see a long distance also. The average highest distance between the eye and the object, which we can see the object very clearly and comfortably, is called maximum distance of distinct vision, also called as MDDV. LDDV depends on the age. whereas MDDV does not depends on the age, its value is always infinity. More than 4 times of the radius of curvature of islands, we can say it as infinity. Now let us see angle of vision. Angle of vision. To learn this topic, let us do a small activity. Stand like this and place the thumb like this. Now my eye is able to see the end of the thumb. Right? Why? Because eye and thumb are in a same line. Now I moved this angle, means at a particular angle, for example say 10 degrees average. Now I am able to see the thumb. Now 30 degrees, 40 degrees, 50 degrees. Yes, my eye is able to see the thumb in a partial manner. Now it becomes 60. Yes, we can see. But more than 60, we can't see the thumb, or we can't see the point that is there on the thumb. If we imagine this is 0 degrees and again average of 60 degrees, means between this 0 and 60. If we imagine there is a certain angle is there, that angle is nothing but in that particular angle only we can see the object in a clear manner. That angle is called angle of vision. Now once again see, the maximum angle at which we are able to see the whole object. We should see the total object. Such angle only we should call it as angle of vision. For example, say if you observe the eye of a crocodile, the eye of a crocodile is exactly at the edge of its face. So its angle of vision is 220 degrees. Means a crocodile can see the total average of 220 degrees from its base. But our human being is only just 60 degrees. Means we can see the object only up to 60 degrees only. Beyond the 70 degrees we can't see, but below the 60 degrees we can see. This means that it varies from person to person. Its value of a healthy human eye is around 60 degrees. Right? The angle is below 60, what happens? We can see the whole object, means the total object we can see. If the angle of vision is above the 60 degrees, means the object is located above the 60 degrees from our eyesight, what happens? We can't see the whole object, we can see only part of the object only, we can see only the part of object. So totally we can say LDDV, least distance of distinct vision, is average. MDDV is infinity, angle of vision is 60 degrees. Let us calculate how to calculate the maximum focal length of eye lens. See, we already know our eye lens has an ability to adjust its focal length under the action of CLRE muscles. It may extend its maximum value and as well as a minimum value. Now let us see how to calculate maximum focal length of eye lens. Maximum focal length is what? See, if you consider this is the principal axis and as well as eye lens, and backside of the eye lens retina is there, we already know. In this case, the object is at infinity. When the object is at infinity, the light rays are always travel parallel to the principal axis and fall on the lens and undergo the process of refraction. They converge at a point on the retina. This means at this point we are going to get the image. Now if you measure the distance between the eye lens and as well as the image, this distance is called image distance. Image distance is represented by letter V. This distance is always 2.5 centimeters. Now, if the object is at infinity, the symbol of infinity is given here. As per the sign conventions, we already know the direction of measurement, if we consider object distance, first of all object distance here it is considered as minus. Why it is minus? Because the light rays are traveling, if we consider the light rays are traveling from left to right, your measurement is in the opposite direction, that is from right to left. Both the directions are in the opposite direction, so for that we should consider it as negative. Now comes to the object distance. The direction of measurement of the object distance and the direction of the incident rays, both of them are in the same direction, so it is considered as plus 2.5 centimeters. Here we should find out the focal length. Now comes to this, we know this formula is called lens formula. From the lens formula, what is the lens formula? 1 by f is equals to 1 by v minus 1 by u. Now let us apply all the things in the lens formula. 1 by f is equals to, instead of v we should write 2.5 centimeters minus of minus 1 by infinity. Why? Because instead of u we should write infinity. Next step, 1 by f is equals to 1 by 2.5 as it is, minus minus becomes plus, so it becomes 1 by infinity is nothing but 0. We already know that. Now it becomes 1 by f is equals to 1 by 2.5. In the denominator f is there, here 2.5 is there. By reciprocating them, we can get f is equals to 2.5 centimeters. What is this f here? Maximum focal length of eye lens is 2.5 centimeters. Means whenever we saw the object which is at infinity distance, the focal length of eye lens changes up to 2.5 centimeters only. This 2.5 centimeters is the maximum focal length of eye lens. Let us come to know how to calculate the minimum focal length of eye lens. To calculate the minimum focal length of eye lens, we should consider the value of LDDV. The value of LDDV is 25 centimeters. Least distance of distinct vision. Beyond that limit, we can't see the object. Now see, if the object is here, the light rays travel like this and they fall on the lens, undergo the process of refraction and they meet at the point that is there on the retina. So that distance is called image distance. So here image distance is always 2.5 centimeters. Consider the object is at LDDV, that is nothing but average is 25 centimeters. Now in this case we should find out the focal length of the eye lens. Now see here, as per the sign convention, first one is object distance we consider. See, always every distance should be measured from the optic center. So we are measuring in the opposite direction of incident rays. So for that we should consider that one as negative. Now if you observe here, object distance, the object is on the retina represented by letter V, you should be considered as plus 2.5 centimeters. Why? Because the direction of incident rays and the direction of measurement, both of them are in the same direction. So we should consider this value as plus 2.5 centimeters. Now in this case we should find out the value of f. We know that the lens formula is 1 by f is equals to 1 by v minus 1 by u. Let us substitute these values in this formula. Now we can get 1 by f is equals to 1 by 2.5 minus of minus 1 by 25. Next step, 1 by f is equals to, in the denominator one digit is there. To remove the digit we can multiply with the 10 by 10, so that it becomes in the numerator it becomes 10. 2.5 into 10 it becomes 25. Minus into minus becomes a plus and 1 by 25. Now let us see, if you take the LCM for that, on the left hand side 1 by f is there, equals to LCM is 25. In the numerator you can get 10 plus 1. That means 1 by f is equals to 11 by 25. but I required f. So by reciprocating, we can get 25 by 11. The value is 2.27 centimeters. What does it mean? The eye will reduce its focal length up to a value of 2.27 centimeters. Maximum limit of focal length of eye lens is 2.5 centimeters. Minimum focal length is 2.27 centimeters. This means our eye has an ability to adjust its focal length to a maximum limit and as well as a minimum limit. The maximum limit is 2.5 centimeters. The minimum limit is 2.27 centimeters. Now let us discuss what is meaning of accommodation. Now we already know that the focal length of eye lens is adjusted to a maximum value and as well as a minimum value. Why this is happening? Because of the action of ciliary muscles. We already know that ciliary muscles are controlling the focal length of eye lens. Whenever they are expanded and as well as contracted, the focal length of eye lens may increase and as well as decrease. That means our eye lens has an ability to adjust its focal length by itself to a maximum limit, that is 2.5 centimeters, and to a minimum limit, that is 2.27 centimeters. This ability is called accommodation. Now see this definition clearly. The ability of adjusting the focal length of eye lens by itself to a maximum value. The maximum value is 2.5 centimeters, and to a minimum value, and to a that minimum value is 2.27 centimeters. This ability is called accommodation.